Welcome back. We're going to talk in this video about solving a system of equations by substitution. A classic type of example, and we're going to talk about a little bit why and go through the step-by-step to solve it. First, we're going to be solving by finding an x value and a y value that will satisfy the top equation. We'll label it 1, and the bottom equation we'll label it 2. The first step here is to solve for a variable. Now, this is why this is a classic example. We have a variable already solved for us. We have y by itself. We know that y equals 2x minus 5. And so that part is already done for us. We can check that off. The second step is to substitute the expression the variable equals in the other equation. So I'm going to take 2x minus 5 and put it into the other equation in substitution for y. And let's write out what that looks like. So I have 5x minus 4, and then instead of y in our first equation, I put 2x minus 5, because I know that's what y equals. And then I continue it, equals negative 10. So this is a version of number 1, but I substituted the expression y equals in for y. And then if it's boxed up like this, I can put parentheses around it. 4 is being multiplied, or negative 4 is being multiplied to this expression. So I'll put parentheses around that. And now I've substituted. The third step is to solve the one variable equation. So when I look at an equation like this and it's one variable, I first think distributive property. I'm going to write out 5x, and then I'm going to multiply negative 4 times 2x. I get negative 8x. And then multiply negative 4 times negative 5, I get positive 20. And then write out the rest of it, equals negative 10. Now the next step is going to be to combine like terms. We have 5x and negative 8x. Combining those together, we're going to get negative 3x. Then we have our inverse operations. I want to get x by itself, so I'm going to subtract 20 from both sides. I get negative 3x equals negative 30. And then I'm going to divide both sides by negative 3 to get x equals 10. So I've solved the one variable equation. That means that the x value in this solution has to be equal to 10. Now if x equals 10, we're on to our last step, is to substitute the value in place of the variable in one of the two original equations. So I take my two original equations. I know that if x equals 10, I can put that in substitution for x. So in the first equation and the second equation, I can substitute 10 for x. And this is what they look like. And now it's really up to me which one I want to solve. And I can look at these and say, okay, I have a equation 1 becomes a two-step equation, and equation 2 down here just has 2 times 10 minus 5. I know that 2 times 10 is 20, 20 minus 5 gives me 15. So I know that y must be 15 in this bottom equation. And I can always check to see if that's true. I put it up here. 5 times 10 is 50, then 4 times 15 is 60. So 50 minus 60 does give me negative 10. So it's true for both equations. And I can substitute y in for the rest of the coordinate. So my answer is 10, 15 as my solution. That satisfies both of these equations. Please feel free to leave a comment letting me know any questions you have. As always, be kind to yourself, be kind to others. I hope you have a great day.